Tsunami magnitude 0 to 1. Micro tsunamis. Without sensitive oceanographic equipment, tsunamis of this scale are rarely detectable. Micro tsunamis, which measure less than 0.3 meters, 1 foot, occur often in oceans worldwide. They often originate from minor submarine shocks or distant seismic activity that does not displace enough water. These waves can cross oceans undetected due to their modest amplitudes and lengthy wavelengths. Coastal residents won't notice unusual water movement or physical damage. These incidents largely interest geologists and oceanographers studying ocean wave patterns and earthquake ripple effects academically. They are innocuous, but remind us of the continual seismic activity beneath the oceans. Tsunami magnitude 2. Very minor tsunami. Very small tsunamis are 0.3 to 1 meter, 1 to 3.3 feet. Although modest, these waves can create perceptible but harmless sea level fluctuations in coastal areas. The ocean sometimes recedes or surges without warning, simulating strange tidal behavior. Moderate submarine earthquakes cause these episodes, but the energy dissipates before reaching shore. The average beachgoer may see the tsunami as a strong tide or an abrupt ocean change. Small boats, swimmers, and those on weak docks may still be at risk from this wave. Even this large wave surge could surprise unprepared people. Ocean monitoring stations record and archive seismic data for seismic study, but emergency alarms are infrequent. Tsunami magnitude 3. Minor tsunamis at this level produce wave heights between 1 to 2 meters, or 3.3 to 6.6 feet. This is when the effects become visibly noticeable and potentially disruptive. These minor tsunamis are capable of causing light flooding in low-lying areas, especially harbors, bays, and estuaries. Docks and marinas may experience some damage as the surging water lifts and slams small boats, and the sudden current can unmoor vessels or capsize those anchored too close to shore. Lightweight beachside structures such as kiosks, sheds, or poorly built homes might also suffer from water intrusion. These events may not claim lives in most cases, but they serve as critical warnings for what larger tsunamis could do. Authorities may issue advisories urging people to stay away from the water, though widespread evacuations are unlikely. Minor tsunamis are often mistaken for storm surges or unusual tidal patterns, especially in places without advanced tsunami warning systems. Tsunami magnitude 4. Moderate tsunami. Moderate tsunamis produce wave heights from 2 to 4 meters, 6.6 to 13 feet, which is enough to cause significant concern among coastal population. These waves have the strength to push deep into coastal areas, flooding roads, damaging buildings, and overwhelming poorly constructed infrastructure. Moderate tsunamis typically occur after a strong offshore earthquake, usually between magnitude 6.5 and 7.5 on the Richter scale. The surge can uproot trees, sweep away vehicles, and cause widespread panic among residents. Harbors may be rendered unusable due to sunken boats or broken docks, and beachfront homes can suffer major structural damage. In many cases, tsunami sirens are activated, and emergency responders issue evacuation orders to prevent injury and loss of life. If a region has poor infrastructure or lacks natural barriers like cliffs or dunes, the devastation can be disproportionately high. In countries with active seismic zones and coastline, like Indonesia, Japan, or Chile, moderate tsunamis are taken very seriously and often prompt nationwide alerts. Tsunami magnitude 5. Strong tsunami. A strong tsunami features wave heights ranging from 4 to 10 meters, 13 to 33 feet, capable of massive destruction over a wide area. At this level, the tsunami surge can travel several kilometers inland, carrying with it the energy to flatten homes, collapse bridges, and destroy power lines. Entire communities situated along coastlines are at risk, and evacuations become not just advisable, but absolutely essential. The water surge from a strong tsunami behaves more like a liquid bulldozer than a typical ocean wave. It can drag cars, uproot entire trees, destroy buildings, and severely erode the coastline. After the water recedes, the landscape is often unrecognizable, covered in mud, wreckage, and debris. These tsunamis are typically triggered by earthquakes above magnitude 7.5 and are often followed by dangerous aftershocks. In addition to physical destruction, strong tsunamis often result in significant casualties, displacement of populations, and long-term economic damage. Recovery can take years, particularly in developing nations without access to international aid. Tsunami magnitude 6. Major tsunami. A major tsunami has wave heights that exceed 10 meters, 233 feet, making it a severe region-wide natural disaster. These tsunamis obliterate coastal towns, shatter infrastructure, and often leave tens of thousands homeless. Reinforced concrete buildings may collapse, transportation systems are destroyed, and critical services such as hospitals and communication networks are knocked offline. Major tsunamis can inundate inland areas for several kilometers, turning bustling cities into lakes of debris and sewage. One of the most devastating modern examples is the 2011 tsunami in Japan, where some waves reached over 40 meters high and killed over 15,000 people. The impact also triggered one of the worst nuclear disasters in history at the Fukushima Daiichi power plant. The psychological trauma, loss of life, and environmental consequences of major tsunamis are nearly unparalleled in the natural disaster category. International aid, military involvement, and long-term rebuilding programs are often required to restore some sense of normalcy in the aftermath. Tsunami magnitude 7. Catastrophic tsunami. Catastrophic tsunamis are defined by wave heights exceeding 20 meters, 66 feet, but the destruction they unleash far surpasses mere numbers. These tsunamis level entire coastlines, cause massive death tolls, and change the geography of entire regions. They are often triggered by magnitude 9.0 plus megathrust earthquakes, which displace enormous sections of the seafloor. The resulting waves can travel across oceans at speeds of up to 800 kilometers per hour, 500 miles per hour, hitting shores hours later with the power of an unstoppable force. The 2004 Indian Ocean tsunami stands as a haunting example. It killed more than 230,000 people across 14 countries and left over 1.7 million people displaced. Entire cities were wiped out, coral reefs and marine ecosystems destroyed, and economies of small island nations collapsed overnight. In many places, the only warning was the ocean suddenly pulling back, only to return moments later in a wave the height of a 7-story building. These are the kinds of events that make history books and permanently reshape nations. Tsunami magnitude 8. Mega tsunami researchers use the phrase mega tsunami to describe waves above 40 meters, 131 feet, tall caused by non-seismic events such major landslides or asteroid impact. Most tsunami warning systems don't use it. Mega tsunamis form quickly when a massive mass of material displaces the sea, unlike ordinary tsunamis that gradually build up. The 1958 Lituya Bay mega tsunami in Alaska, caused by a rock slide, was the most renowned. It destroyed everything in its path, removing mountaintop trees and soil. Mega tsunamis are rare but dangerous due to their quick onset and immense force. A strike on a populous region would cause unimaginable death and destruction. They reflect the worst tsunami impact. Hypothetical asteroid-induced tsunami. The worst ocean-based disaster is asteroid-induced tsunamis, which are not classified by magnitude. A 1-kilometer diameter asteroid might cause tsunamis hundreds or thousands of meters high. These waves might spread over oceans and hit continents with cataclysmic fury. The asteroid that killed the dinosaurs 66 million years ago may have caused global mega tsunamis exceeding 1.5 kilometers tall. Impact energy could change global temperature, create vast dust clouds, and disrupt food chains for generations. To prevent this, governments and NASA track near-Earth objects carefully. Despite the minimal probability of an asteroid-induced tsunami in our lifetime, global catastrophe preparation takes it seriously. If you found this video helpful and fascinating, don't forget to like, subscribe, and click the bell icon for more deep dives into Earth's most powerful forces. And let us know in the comments, which tsunami magnitude surprised you the most? Until next time, stay safe, stay informed.